Good morning, class. We are looking at chapter 1 review, functions and models for calculus 1. We're going to cover the whole chapter in this case, and it covers 4 ways to represent the function, mathematical models, a catalog of essential functions, new functions from old functions, exponential functions, inverse functions, and logs. Four ways to represent a function. We can do it verbally by a description in words, numerically by a table of values, visually by a graph, algebraically by an explicit formula. Here's the function machine representing f of x. We input the x, in other words, the concept of a domain, and the output is f of x, the concept of a range. So x comma f of x such that x is an element of the domain. This, which looks like an epsilon, is read an element of in set theory. Vertical line test, you've heard of it. The vertical line test, a curve in the xy plane is the graph of a function of x if and only if no vertical line intersects the curve more than once. Vertical line test. A function f is called increasing on an interval of I if f of x sub 1 less than f of x sub 2, whenever x sub 1 is less than x sub 2 in the interval of I, and it's called decreasing if f of x sub 1 is larger than f of x sub 2, whenever x sub 1 is less than x sub 2 in I. In short, increasing means when x gets larger, so does y. Decreasing means when x gets larger, y gets smaller. That's the synopsis of this concept. Horizontal line test. A function is one-to-one if and only if no horizontal line intersects its graph more than once. In other words, class, for a vertical line, for a function, for something to represent the function, it has to pass a vertical line test, meaning the x coordinate cannot repeat. For it to be one-to-one, it has to pass a horizontal line test. That means the y coordinates can't repeat. If that happens, then we have an inverse function, f inverse of f of x, or f of f inverse of x. Both of them are x. In this case, as long as x is in A and x in B, where A and B represent the domain of the function f of x and f inverse. So in short, f of f inverse equals f inverse of f equals x. What is an even function? F of minus x equals f of x. What is an odd function? F of minus x equals minus f of x. So those are some of the definitions that we needed to get started with. Here's the function f of x equals x squared minus 4 over x plus 2. We are asked to find the domain. To find the domain of the function in a case of rational function, you set the denominator equal to 0 and you exclude that. Okay, so x plus 2 equal to 0, x becomes negative 2 and you exclude that. Now, this is the shorthand version of that. An interval notation would be minus infinity, comma, -2, union -2, comma, infinity, this is called the interval notation. So remember, when we have parentheses, we are excluding the end points. For a case like this, we do the same thing. We set the denominator equal to 0 and we exclude that. So when we want to do that, we are going to factor this. We want two numbers, the product is -10, the sum is +3. So those are 5 and -2. And so x can't be -5, x can't be +2. So for this one, x can't be -5. For this one, x can't be +2. And here's the interval notation. The domain is from -infinity to -5, union -5 to 2, union 2 to infinity. Is f of x equals x squared minus 4 over x plus 2 equal to x minus 2? Well, let's find out. The top is in the form of a squared minus b squared, which can be factored into a minus b, a plus b. 4 is 2 squared, so it becomes x minus 2, x plus 2. And we can cancel out the x plus 2 from the top and the bottom, and it's equal to x minus 2. However, this works if this is not 0. When you set this equal to 0, you get -2, you have to exclude that. So what would be the difference? If you were to graph y equals x minus 2, that would give you a line. If you were to graph this function, would be the same line with a hole where x is equal to -2. So they are not identical. So one more time. This would be a line. This would be the same line with a hole. At what point? At x equals -2. Again, just reminding you, all of these PowerPoints are available under the modules. Determine whether each of the following functions is even, odd, or neither. And I'm reminding you of the definition of even versus odd. So basically, all you have to do, replace the x with minus x and observe. So for the first one, f of minus x becomes minus x to the power of 5 plus minus x. As you can see, this becomes minus x to the power of 5 minus x, and we can factor the negative out, and therefore it makes it minus f of x, which is an odd function. G of x equals 1 minus x to the power of 4. Let's evaluate g of minus x. Because this exponent is even, minus x to the power of 4 is the same as x to the power of 4, which makes it the same as the original function. And therefore, by definition of an even function, it makes it an even function. So g is an even function. Let's work on h of x by evaluating h of minus x. Replace the x with minus x. So this is negative 2x. This is positive x squared, but with this negative in front still becomes minus x squared. So when you compare this to the original function h of x, it's not equal to that. So it's not even. It's not equal to its opposite. That means minus h of x. So it's neither even nor odd. Here's the function given. Where is the function increasing? So we should clearly see the function is increasing here. So the x coordinates from -4 to 0. So you can say x is between -4 and 0 or in the form of an interval format. What's important at the end points, namely -4 and 0, we can't include those because we don't know what's happening. Now, where is this function decreasing? It's decreasing here, it's decreasing here, right? This makes it from -6 to -4, and this makes it from 1 to 3 to 6 with the union. So -6 comma -4 union 3 to 6. The endpoints are not included. Where is this constant? Where is this function constant? When it has a horizontal line or line segment in this case. So this part, which is from here 0 to here 3. Anybody wants to read this question for us?
I can do that.
Thanks, Peter.
As dry air moves upward, it expands and cools. If the ground temperature is 20 degrees Celsius and the temperature at a height of 1 kilometer is 10 degrees Celsius, express the temperature T in Celsius degrees as a function of the height h in kilometers, assuming that a linear model is appropriate. B, draw the graph of the function. What does the slope represent?
Excellent. Thank you so much. So what we are going to do, we are going to solve it by noticing that the pairs are going to have h and t, the height and the temperature. So with that being the case, the ground has a height of 0, temperature of 20 degrees Celsius. 1 kilometer, the height of 1 kilometer will have 10 degrees Celsius. And as far as the units are concerned, we are going to go with the height in kilometers. Now, as you know, because we are representing this as a linear function, we have to find the slope, which is rise over run. Normally, it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Everybody remembers that. Because we are using h and t, we are going to say t sub 2 minus t sub 1. Look, instead of y, we're going to go with t. Instead of x, we're going to go with h sub 2 minus h sub 1. So that makes it 10 minus 20 over 1 minus 0, which results in minus 10. If we were to write the units of the numerator, that means temperature, over the units of the denominator, that means height in kilometers, okay? So we would say degrees Celsius per kilometers. That would be the units. It is extremely important to write the units and understand what they mean, because by definition, rise over run, the average rate of change of y with respect to x, in this case, the average rate of change of temperature with respect to the height. We know y equals mx plus b, and the reason this is the slope-intercept format. The reason I'm going to use that because the y-intercept, in this case, the t-intercept is given to us as 0, 20. So y equals mx becomes minus a 10 h. So m is minus 10. X, we're going to replace it with h. And the y-intercept now is the t-intercept plus 20. So again, I want you to compare and contrast and see how we can easily come up with the equation. First, I'm going to write y equals mx plus b. I'm going to use the m from here. Instead of x, I'm going to use h. And 0b, now it's 0t. The y-intercept. Okay. It is still in essence 0b, but it represents instead of the y-intercept, it represents the t-intercept. That's the idea behind that. Now, t-intercept, 0, 20, h-intercept. If you set this one equal to 0, that means replace the t with 0, everybody. This is 0. H becomes 2. Okay. And this simply put means at the height of 0 at the ground level, we have a temperature of 20 degrees. At the height of 2 what? 2 kilometers, we have a temperature of 0 degrees Celsius. And I'm going to assume everybody can graph this nice and easy. Okay, 0, 20, 2, 0. And by the way, the h and t, they don't have to have the same scale. And here's the graph. Okay. And we don't go to the left of 0 because this represents the height, the x-axis, which is now the h-axis. So we don't go negative. The slope is m, or negative 10 degrees Celsius per kilometer. It represents the rate of change of temperature with respect to height. Okay. For every kilometer that we increase the height, we decrease the temperature by 10 degrees Celsius. That's really the bottom line. What is the temperature at a height of 2.5 kilometers? 2.5. Replace the h with 2.5. minus 10 times 2.5 is negative 25 plus 20 is negative 5 degrees Celsius, according to this formula. New functions from old ones, some sort of a transformation. Granted, when it gets complicated, you can use a graphing calculator, but the general idea should be very clear. If we have this function y equals f of x, when we add plus c, it shifts up by c. When we subtract c, it shifts down by c. If you say f of x plus c moves to the left by c, and if it's f of x minus c moves to the right by c, we are assuming c is positive. Sometimes they call it translation, sometimes they call it transformation. It's the same thing. Again, you have y equals f of x. If you assume c is larger than 1 and you multiply it by that, it increases by that much because that's what happens to the y coordinate. If you have 1 over c, let's say 1 over 5, it makes it smaller. Now, if you put the negative in front of f of x, it flips this over with respect to the x-axis. If you put it in front of x, f of minus x, it flips over with respect to the y-axis, so on and so forth. Algebra of functions, the sum function, the difference function, the product function, the quotient function. F plus g of x is f of x plus g of x. F minus g of x is f of x minus g of x. F g of x is f of x times g of x. F over g of x is f of x over g of x. Needless to say, as always, class, the denominator can't be 0. So here's what we have. The domain for if the function f, let's say it's a, and the domain for function g, let's assume it's b. Then the domain of all of them are a intersection b. The last one is the same thing, and whatever makes g of x 0 is excluded. So x is an element of a intersection b. Also, whatever makes the denominator 0 is gone. F of g by definition is f of g of x. G of f by definition is g of f of x. The composite functions, f of g and g of f are not the same. Okay. And they become the same if the two are inverse functions, such that f of g equals g of f equals x. F of f inverse equals f inverse o f. All right. Absolute value of a function, if y is absolute value of f of x. Absolute value of f of x equals f of x is f of x is greater than or equal to 0, meaning there's no difference. However, it's the opposite of that. Minus f of x is f of x is negative. And I remind you of absolute value of x, which is x. If x is non-negative or greater than or equal to 0, minus x if x is less than 0. Okay, so I hope it's clear to everybody. So we want to sketch the graph of the following function. So first and foremost, I want you to see how this graph works. You ignore the absolute value function, okay, and you graph the function of x squared minus 25. Okay, so in general, the part of the graph of f of x, according to this, that lies above the x-axis remains the same. The part that lies below the x-axis is reflected about the x-axis. So we are going to graph this, which is y equals x squared, now shifted down by 25 units, looking like that. The blue portion is above the x-axis and it's positive, so it makes no difference. The blue portions remain unchanged. The yellow one is below the x-axis and therefore negative. It flips over. Flips over. Okay, everybody? Now it flips over. I hope everybody is fine with that. Y equals absolute value of square root of x minus 1. So first, I'm going to ignore the absolute value inside the square root of x minus 1. And I'm going to just look at one of those essential functions, an elementary function. We should know the graph. So y equals square root of x looks like that. Everybody should know that. Now I'm going to go with y equals square root of x minus 1, which is the same function, minus 1, shifted down by 1 unit. So I'm going to take this down by 1 unit. When I take it down by 1 unit, now 0, 0 moves to negative 1, 0. One, 1 moves to 1, 0. Okay, so far so good. So take a look. We want the absolute value, and this portion is above the x-axis. This portion will not change. This is below the x-axis. So flip it over. Looking like that. So this is the graph of y equals absolute value of square root of x minus 1. That's how you do that. So again, just like this one, the one below the x-axis flips over. The one below the x-axis flips over. So that is the final graph. Find the domain of the function when we want to find the domain of any square root function when the index is even. You set what's underneath larger than or equal to 0. So x larger than or equal to 0 or 0 to infinity. For g of x, we do the same thing. 2 minus x larger than or equal to 0. If you move this here, 2 larger than or equal to 0, or x less than or equal, so I hope you recognize, or x less than or equal to 2, and here's the domain, negative infinity to 2. By the way, infinity as well as negative infinity, both of them are concepts, not numbers. Therefore, you go with parentheses, meaning the endpoints are not included. What about f plus g of x and f over g of x? We want to see how we find their domain. Basically, for this one, the intersection of these two. In other words, what is in common for this one and this one? It may make it a tad easier if we draw the graph for this one and draw the graph for this one and say, for this one goes from 0 to infinity for this one goes from negative infinity to 2. If you put them together, what's in common? Anything between 0 and 2. That would be the answer for part C. What about part D? The answer is the same, however. So it's the same as this one, however, whatever makes this one 0 is out. So we're going to write x is an element of A intersection B, but g of x equals 0 must be out. So everything works out here. Let's see what makes this expression 0, or this expression, if you will. At x equals 2, this is 0. So this means anything from 0 to 2, including 0 and 2 are fine. For this one, we just can't have the 2 because 2 makes the denominator 0. So again, justification would be if you set this one equal to 0, x becomes 2, and this cannot happen. So the same as this one, exclude the 2. How do you exclude the 2? Bracket changes to parentheses. Example 7, f of x is square root of x minus 3. G of x is x squared, h of x is x cubed plus 6. We want to find f o g o h. You have to do 2 of them at a time. So for example, if I want to find f o g, which is f of g of x, I basically replace this with x squared, and I get square root of x squared minus 3. And then if I want f o g of h, that means I'm going to replace the x here with this expression. So I'm going to replace this with x cubed plus 6 in a parenthesis quantity squared, and this is f o g o h. I highly recommend you try the second method. Find GOH first and then f of GOH. In other words, what we found here was f of GOH. Okay. You can try finding this one first. Try that. Either way is fine. So we found f of g first, then f of GOH. Find GOH and then f of that. Either way is fine. In other words, this is finally, let me just like so. OH, this is capital O. All right. Let's remind you of exponential functions. F of x equals a to the power of x or b to the power of x, whatever the base is, it doesn't matter. This base must be positive and can't be 1. And it makes it a continuous function. These are exponential rules. A to the power of 0 is 1, a to the power of m times a to the power of n is a to the power of m plus n, and the rest of them, this is the product rule, quotient rule, a ratio to the power of n, negative exponential rule, again negative, this is the power rule. All right, so various exponential rules. Now, when you have a to the power of x or b to the power of x, it makes no difference. Okay, some sort of a base to the power of x. When the base is positive, it is an exponential growth. When it's 1, it is not an exponential function. It is a horizontal line. When it's between 0 and 1, it's a exponential decay. All of it, regardless of what they are, there is a horizontal asymptote, which is the x-axis with the equation of y equals 0. We don't have a vertical axis. All of them have a y-intercept of 0, 1. None of them has an x-intercept. The domain, all real numbers. The range 0 to infinity. We're talking about these two, okay, class? We're talking about these two. The range from 0 to infinity, 0 is not included. 0 is not included. So when b is larger than 1, we mean this one, the limit of f of x as x approaches infinity is infinity. That means the first quadrant. And the limit of f of x as x approaches minus infinity is 0. That is the definition of a horizontal asymptote. Whereas b being between 0 and 1, which makes it decreasing, the limit of f of x as x approaches infinity is 0, which is the definition of horizontal asymptote, and limit of f of x as x approaches minus infinity is infinity, the second quadrant. It blows up here. So we want to distinguish between the two. Okay. All right, so what is important is that we know the general shape of any essential graph. So exponential functions are one of those. We should be very comfortable with. Okay, it's easy to make a mistake, so you want to be very careful. Remember all types of essential functions. Okay, including exponential functions. Let's look at this example. We are asked to sketch the graph of this function y equals half of e to the power minus x minus 1 and determine its domain and range. So we're going to start with the basic y equals e to the power of x. Because the base e, as you know, it's the base of a natural log 2.712, and it continues indefinitely. It's larger than 1, and it looks like the b to the power of x that we showed in the previous page. So that's very straightforward. Now, so that's that one. We're going to go with e to the power of minus x. So we're going to reflect it across the y-axis. So this is e to the power of x. And in order to go from this to e to the power of minus x, just reflect it. Okay. About the y-axis. And it looks like this. So we got from e to the power of x to e to the power minus x. And the next one is to take care of 1/2. So we want to multiply that 1 by 1/2. So the third step is to compress the graph vertically by a factor of 2, make it smaller, half of e to the power minus x. So this becomes smaller. And the result is that this was located at 0. Okay, let me just write it. Same thing here. And the y-intercept now is located at 0, 1/2. Finally, we're going to use the -1. That means bring this down shifted down by 1 unit. So we're going to bring this down by 1. And when we do that, first of all, 0, 1/2 becomes 0, negative 1/2. Secondly, this x-axis was the horizontal asymptote. It shifts down by 1 unit. So y equals negative 1 is the horizontal asymptote. So what is the effect on the domain and range? The domain doesn't change, still negative to positive infinity, negative to positive infinity, but the range was 0 to infinity in all these cases. But this one, now that it has gone down, it has had an effect on the range. The range goes from -1 to infinity. Range means all the possible values of y. Domain means all the possible values of x. Domain is the same as before. All real numbers, you may show it in this fashion or in this fashion. All real numbers, but the range is going from -1 to infinity, and needless to say, -1 is not included. All right. We want to figure out the domain for this function, g of t equals square root of 10 to the power of t minus 100. Because it's a square root, by the way, again, if the index is odd, the domain is all real numbers. The index, when we don't write it, the index is 2, class. This one means the index is 2, but over here we write it, the index is 3. Over here, the index is 4. Or this one, the index is 10. So that means the root, that means cube root, the 4th root, the 10th root, the index. When the index is odd, there is no restriction on the domain. So 10 to the power of t minus 100 is greater than or equal to 100. We're going to move this to the right, make it positive 100 or 10 squared. So 10 to the power of t compared to 10 to the power of 2. So t must be greater than or equal to 2. And this is fine if you want to write it as an interval format. Bracket 2 comma infinity. As far as the sign is concerned, if I want to remind you that if we had y equals sine x, the domain was all real numbers. And since this expression is replacing the x with no restriction when it comes to the domain, why there is no restriction? Because as you know, e to the power of t, the domain is all real numbers. If you subtract 1, add 1, do whatever, the domain is not changing. Okay? So the domain of this one, just like the x, has no restrictions. Y equals sine x as the domain of all real numbers, so does this one. We want to solve this equation. The product rule. Okay. So the left side is e to the power of x squared plus the parentheses 2x plus 1 equals e to the power of t. Therefore, this exponent must equal this exponent, and you're done. We want to find the inverse function. What is the process? Number one, we're going to change f of x to y because it makes life easy for the sake of calculation. That's the only reason, because remember, y and f of x, g of x, h of x. If it's g of x or h of x, makes no difference to change it to y. The second step is to interchange x and y. This becomes x, this becomes y, this becomes y. And right in this step, right here, we do have the inverse function. However, normally we solve for y, and that's what we are going to do. So I'm going to treat this as a proportion. And I say if I multiply these two, that I get 2xy plus 3x is the same as multiplying these two, that I get 4y minus 1. This is my third step that I'm trying to solve for y. Because I want to solve for y, I'm going to move things around, which means this one involving y moves this way, this one moves this way, and they change sign. On the right side, I'm going to take the y out. Of course, I can take 2y out, but I just want to solve for y. Okay, class? And the next step would be to divide by 4 minus 2x. By the way, if when we get here, there is a common factor of 2, in the numerator, we have to take it out. Now we give it the name f inverse, that's all. And you really have to work it out and show that f of f inverse equals f inverse of equals x. You have to show at least one of them. I'm going to quickly show one of them, and so I'm going to clean up. For example, if I want to go with f of f inverse, 4 times x minus 1, 2 times x plus 3, and I'm going to put 3x plus 1. Oh, just use 3x plus 1. Over 4 minus 2x. I have a hard time writing here. Sorry, class. Over 4 minus 2x. So I hope you understood what I'm trying to do here, okay? I am finding the composite function, everybody. And so to simplify this complex fraction, I'm going to multiply the top and the bottom by LCD, which is 4 minus 2x. So if I apply this to the first one, I get 4 minus 2x drops times the numerator, 3x plus 1, minus 1 times 4 minus 2x, And for the bottom, 4 minus 2x drops, I get 4. 2 times 3x plus 1 plus 3 times 4 minus 2x. I'm simplifying the complex fraction. So let me use a different color now, and let's see, maybe this one. So the numerator is 12x plus 4 minus 4 plus 2x, 6x plus 2 plus 12 minus 6x. The top is 4 and minus 4 cancel each other, 14x. The bottom 6 and minus 6x cancel each other over 14. It becomes x. And I just proved that I haven't made a mistake. I know it's messy, class, but in case somebody has some problem with complex functions, I just wanted you to be exposed to it. That's the only reason I did that. You should have no problem with that, but in case if you do, I hope that it's taken care of now. But I highly recommend, to be on the safe side, you try to come up with this one, okay? Okay, so at least you have an idea how to do that in case anybody has any problem with complex fractions. Okay. Here's the function f of x equals 1 minus e to the power minus x over 1 plus e to the power minus x. We want to find the inverse. This is a little bit more challenging. So the very first thing we do, again, the f of x changes to y. The second step is to interchange x and y. So this becomes x, this becomes y, this becomes y. We write this as x over 1, and we do the cross product, these two and these two. So x times 1 plus e to the power minus y equals 1 minus e to the power minus y. And we distribute the x. This becomes x, this becomes x e to the power of minus y. The right side doesn't change. Now, to get rid of the negative exponent, and you can write this as 1 over e to the power of y. Please understand, this class is the same as minus 1 over e to the power of y. The same thing for the other one. So to get rid of the negative, we multiply both sides by e to the power of y. So what happens when we do that? This becomes e to the power of y times x. This becomes x e to the power minus y times this one. These two, remember, cancel each other, they give us 1. 1 times e to the power of y, these two cancel each other, they give us 1. So this is therefore e to the power of yx plus x equals e to the power of y minus 1. Since we are trying to solve for y, we are going to move this one to the left, becomes negative. This one to the left becomes, to the right becomes negative. And we are going to factor out e to the power of y on the left. X minus 1 comes out, divide by. So e to the power of y is minus x minus 1 over x minus 1. Okay. Or I want to show you how I change this to this one. If you take the negative sign out from the numerator, you get x plus 1. If you give it to the bottom, you get minus x plus 1 or 1 minus x. It's the advantage is we have less negative numbers. I hope everybody's okay with that. Okay. Now we go to the definition of exponential functions. And y becomes a natural log. Or take a natural log of the left side, natural log of the right side. Either way gives you this answer. Change the name y to f inverse, you're done. And this is as complicated as it gets. If you could follow that, you have no problem with any inverse function. And again, inverse functions can be interesting sometimes. Okay, class? Log. Let's look at logs. If b is larger than 0 and b can't be 1, then y equals log x base b is equivalent to x equals b to the power of y. This is the exponential format. What I want you to do, pay attention to what I'm going to show you here in case anybody has any difficulties with logs. Look at the arrow, b to the power of y. So if you go with this arrow, means b to the power of y is x. And if we can go from logarithmic format to exponential format, back and forth, we are in good shape. That's all there is to it, everybody. If we can do that, we are in good shape. I can't emphasize this enough, okay? Now, general log properties, y equals log x base b, or sometimes we say log x to the base b or log to the base b of x. That means b to the y power of y is x. And these are logarithmic properties you should be comfortable with. Log 1 base b is 0, log b base b is 1, log of b to the power of x base b is x, log b to the power of log x base b is x. This is log of x, y is log x plus log y. The product rule, same base b, log of x over y is log x minus log y. The quotient rule and all of them the same base b, log of x to the power of n is n log x, both have base b. The power rule, the quotient rule, the product rule, and these two refer to the fact that logarithmic functions and exponential functions are inverse of each other. By the way, this is easy to see just by this arrow again, okay? So this means log 1 with any base is 0. This means if the base and the argument, this is called the argument of log, are the same, the answer is always 1. For example, when we go with common log, we are going to use y equals log x, and we won't write the base. The base is 10, we don't write it. It means 10 to the power of y is x. And so these are the rules. I hope you can find the transition nice and easy. The first one doesn't, change anything. It's log 1. 5, 6, 7 don't change. These are the three you want to pay attention to. Y log 10 because log b base b. Because the base is 10, you put it in that format, and the other two, again, just like 3 and 4 here, refer to the fact that logarithmic functions and exponential functions undo each other. Same thing here, y equals ln x is the same as writing log x base b. Please don't write log x base e, okay? Write ln x, you're a calculus student, okay? And then we have these rules, again, these two, we have seen it. The rest of them are very straightforward. Numbers 5, 6, 7 over here, drop the base. Over here, instead of log, use ln. Okay. Now over here, log b base b is 1. Over here, log 10 is 1. Over here, ln e is 1. As an example, if we look at an exponential and logarithmic function with the base e, they are inverse functions and therefore symmetric with respect to the line y equals x. Change of base formula. Log x base b is log x over log b as long as you choose the same base, for example, a. What do we choose? Normally we choose common log or natural log. Okay. Again, pretty straightforward. All right, we want to write as a single log. All right, we want to write as a single log, and we are supposed to be very comfortable with all the logarithmic properties, so it makes life easier that way. So let's do that. One half ln of x plus 2 quantity cube plus 1/2 ln of x minus ln of x squared plus 3x plus 2 squared. We want to write it as a single log. First and foremost, this one, if you look at this one, you can put the n as an exponent. So if you put the 1/3 here, 1/3 times 3 makes it 1. So 1/3 and 3 cancel each other. This is ln of x plus 2. Then we're going to apply the 1/2 here. So here's what's going to happen. We're going to cross this out times 1/3. We're going to cross this out. This is to the power of 1/2. And this is to the power of 1/2, 2 times 1/2. Okay. This is what we get. I hope everybody is comfortable with that. So one more time before we move on. 1/3 becomes the exponent for x plus 2 cubed, so multiply by 1/3. 1/2 becomes the exponent for this one as well as this one. Now these two, we can put them together. And they go at top because this is negative, this goes at the bottom. However, let's rewrite this as a product of x plus 2 and x plus 1 because we want two numbers. The product is 2 and the sum is 3. It's pretty straightforward. I hope everybody's okay with that. All right. So we're going to write ln of this times this, or as you know, it's square root of x. And because this has a negative sign, this goes to the bottom, of course, in a factored form. Why do we put that in factored form? We can get rid of x plus 2. Again, is this the only way? No, but this is probably the fastest way. You can use any properties that you're comfortable with and do the work. Okay, everyone? Here's the next one. We want to write this as a single log, and I hope you recognize that you can put these two together as ln of x plus y times x minus y, which is ln of x squared minus y squared. And because this is 10, I'm going to put it here as the exponent, and this is negative, it goes down. So we put ln of x squared minus y squared over z to the power of 10. Questions? I hope everybody is fine with this. Just stop me if you have any questions, everybody. All right, here's the next one. Now we want to go the reverse process. We are going to expand everybody. So first and foremost, square root means to the power of 1/2. Second, I can put the 1/2 in front. So 1/2 log of x minus 1 over x plus 1. And now, finally, I can use the quotient rule and say log of x minus 1 minus log of x plus 1. So again, I think it's pretty straightforward. There is really not much to it. I am hoping that everybody is fine with that. But if you have a question, please make sure you ask so we can move on. We want to solve this equation, ln of x squared minus 1 equals 3. All we have to do, go through the definition and remember this arrow. Of course, when we don't have a base, but it's ln, the base is e. So x squared minus 1 is e cubed. Let me just actually draw the arrow. So this arrow, okay. X squared minus 1 is e cubed. So x squared is 1 plus e cubed. So x is plus minus the square root of that. And both of them are acceptable because, remember, when you square this becomes positive. And the idea is that the argument of log, regardless of the base, must always be positive, everybody. All right, we're going to move on to this question. And there are two ways to approach this. You could do this just the way it is, or you can do the following. If you, again, just the way it is in a moment, but if you let e to the power of x be something except x, for example, y, I hope you recognize that e to the power of 2x therefore is y squared. So you're dealing with y squared minus 3y plus 2 equal to 0. And you want two numbers, the product is 2, the sum is negative 3, and those are negative 1 and negative 2. Or you don't have to change that, just put e to the power of x. If you go with that, you can write y minus 1, y minus 2, okay? And then replace. Either way. So the first one says e to the power of x is 1, and the second one says e to the power of x must be 2. Okay. And so the first one says e to the power of x is 1. That means x is ln 1 or 0. This one x is ln 2. And I'm going to keep it as ln 2, which is an exact answer. I hope everybody understands how we make this change from one format to the next. Okay? That is extremely important to know it. The change that we make from exponential format to logarithmic format and vice versa. So e to the power of x equals 1. That means ln 1, and we should know ln 1 is 0. All right, ln of ln x equals 1. If it makes it easier, imagine this is y. And so let me write that. So ln y equals 1. and I go with this arrow, and that means e to the power of 1 is y, okay? But y is ln x, so ln x is e to the power of 1 or e. And now we go with the arrow again. X is e to the power of e, and that's a precise answer. This has got to do with the definition of y equals ln x. Here's the next question. We are given e to the power of ax equals c e to the power of bx, and we want to solve for x. The methodology for this case is to divide both sides by e to the power of bx. And using the exponential rule, this is a quotient rule, everybody. This one is e to the power of ax minus bx, and I'm going to take the x out. So e to the power of a minus b times x equals c. If I take the natural log of both sides, the left side becomes a minus b times x, and the right side is just ln c. And all I have to do, divide both sides by a minus b. So divide. And by the way, you can do like this. That means divide both sides by a minus b. And that's your final answer, everybody. You can do it that way. Here's example 14. ln of 2x plus 1 equals 2 minus ln x. We want to solve this. Anytime you have logarithmic equations, if you have all logs, put each side into a single log and solve. But if you have a mixture, then bring all the logs to one side, all the numbers to the other. And so in this case, all we have to do, move minus ln x to the left side becomes plus ln x, combine them using the product rule, ln of 2x plus 1 times x, or x times 2x plus 1. And now by the definition, and I'm going to use the arrow again, x times 2x plus 1 equals e squared. And if it helps, you can even put them in brackets, class, okay? And so distribute the x, you get 2x squared plus x. And we're going to move the e squared, becomes minus e squared. Bear in mind, e is not missing, e is a number, okay? But we're going to keep it as e because we want to get an exact answer. E is 2.71828, and it continues indefinitely. So how do we solve that? We are going to use the quadratic formula, and everybody remembers ax squared plus bx plus c equal to 0. X is minus b plus minus the square root of b squared minus 4ac over 2a. So if that is the case, what is a here? 2. What is b here? 1. What is c here? Negative e squared. So just plug in. We are going to plug in. And when we do that, this is minus 1, this is positive 1, minus and minus is positive 8e squared. There are two answers, and we want to be very careful. We go back to the original function, x here, 2x plus 1. Every argument must be positive. So if I choose the negative one, I don't even have to know what the value is. Minus 1 minus this expression over 4 is a negative value. We can't have it for x. So the only answer is the positive one. So again, There are two answers, positive and negative here. If I choose the negative one, that doesn't work, okay? Because the top is negative, divided by 4 is negative, and x becomes negative, the argument cannot be. This is the one and only answer, everybody. Prove cosine of sine inverse is square root of 1 minus x squared. Let's see how we tackle this question. First and foremost, we let this one represent an arc, an angle, alpha, beta, gamma, theta, your choice, even, you know, since this is x, y, z, it doesn't matter. If this is theta, what are we looking for? We are looking for cosine of theta. So the question is, what is cosine theta? That's what we are going to work on to get to here. So by definition of inverse functions, if sine inverse of x is theta, by definition, sine of theta must be x. Everybody remembers Pythagorean identities in trigonometry. There are three of them. I'm going to go over one of them for now, and there are others. I'll discuss them as we come across it. Sine squared plus cosine squared is 1. Therefore, sine is plus minus the square root of 1 minus cosine squared, and cosine is plus minus the square root of 1 minus sine squared. I hope everybody understands from this formula we can get here. And so what is cosine theta? Either or. Which one is the case? It's the positive one. 1 minus sine squared, and we know that sine of theta is what? So 1 minus x squared. And why do we keep the positive only? Here's the reason. All trigonometric functions, okay, are periodic. None of them is 1-to-1. So we had to do the restriction. Recall, when y is sine x, we restricted the x between negative and positive power 2 in order to make this a 1-to-1 function. And this is the fourth quadrant from minus power 2 to 0, 0 to power 2 the first quadrant, in the fourth quadrant, and in the first quadrant cosine is positive. So plus minus, we just keep the positive. There's a lot of information from trigonometry here, okay, class? Simplify sine of 2 arc cosine x. By the way, we can go with sine inverse or arc sine. We can so go with cosine inverse or arc cosine. That means the same thing. So again, we are going to do what we did here. We let arc cosine x be alpha, beta, gamma, for example, theta. By definition of an inverse function, of course, means cosine theta is x. But what do we want here? The sine of a 2 arc cosine x means the sine of 2 theta. And so first let's write this. This is a cosine theta by definition of an inverse function. When we have this, means cosine theta or cosine x equals theta, so cosine theta must be x. I hope you remember that the sine 2 theta is 2 sine theta cosine theta. So again, information, basic information from trigonometry, I go over it as we come across. Just as we did here. And we said cosine is plus minus square root of 1 minus sine squared. Now sine is plus minus the square root of 1 minus cosine squared theta. So now, if I want to solve this 2 times sine theta, of course, cosine theta, I'm going to replace this with x squared, okay? So that's square root of 1 minus x squared times 2 and then times x. Now, plus minus, remember there are two answers here. We are going to go with the plus sign again only. So plus minus, but we are going to use the plus sign here. And I'll explain to you why. So we have 2, and then sine theta is square root of 1 minus x squared, and then cosine theta is x. Normally we put the x in front. This is the final answer. Why are we choosing the plus one? Well, again, cosine, just like sine, is a periodic function and it's not one-to-one. So the restriction we put on was from 0 to pi, which is the first and the second quadrant. In the first and the second quadrant, sine is positive, so plus minus, we just keep the positive, everybody.